Look up at the night sky, on a clear, dark night. What do you see? A canvas of countless stars, stretching out into infinity. For millennia, humanity has gazed into that vast, dark expanse with wonder, driven by an insatiable curiosity to understand our place in the cosmos. We started with our eyes, the most basic of instruments, then telescopes, magnifying our vision and revealing fainter, more distant objects, and now, we've sent robotic explorers into the void, venturing to the farthest reaches of our solar system and beyond. Each step revealed a universe more complex and beautiful than we imagined, challenging our understanding of physics and the very nature of reality. Now, we have a new eye, the James Webb Space Telescope, the most powerful space telescope ever built, 1,000,000 miles from Earth, far beyond the reach of our planet's atmosphere and light pollution. This isn't just another telescope, it's a time machine, a portal to the early universe, designed to see the universe in infrared light, invisible to our eyes, allowing us to penetrate the veil of cosmic dust. Infrared lets Webb peer through cosmic dust, the very stuff from which stars and planets are born, revealing the first stars and galaxies at the dawn of time, offering a glimpse into the universe's infancy. Its launch in 2021 was a moment of hope and anxiety, a culmination of years of planning and development, the result of decades of work and a multi-billion-pound gamble, a testament to human ingenuity and perseverance. After a flawless journey to the second Lagrange point, a gravitationally stable location in space, Webb unfolded its golden mirror, a marvel of engineering, ready to collect ancient light and unlock the secrets of the universe. Webb's power and precision are unmatched. It can see objects fainter and farther than ever before, pushing the boundaries of our knowledge. It's not just for distant galaxies. Webb's capabilities extend far beyond the extragalactic realm. Webb can also explore our solar system, providing unprecedented views of our celestial neighbors, revealing secrets of planets, moons, and comets, and helping us understand the formation and evolution of our own planetary system. One of its first breathtaking targets, Neptune, a distant world brought into sharp focus, the enigmatic ice giant at the edge of our solar system, now revealed in stunning detail, showcasing its atmospheric features and faint rings. Neptune, named for the Roman god of the sea, a deity of immense power and mystery, is a dark, cold, and distant giant lurking in the mysterious depths of the outer solar system. It resides billions of miles away, a realm of perpetual twilight. It was discovered in 1846, not by chance but through meticulous calculation and observation, but through mathematics, a testament to the power of human intellect and our ability to predict the unseen. Astronomers noticed Uranus, its neighbor, was behaving strangely, its orbit subtly being tugged and perturbed by an unseen object, a gravitational anomaly. They calculated where to look, using complex equations and celestial mechanics. And there it was, a faint blue dot, a world previously unknown to humanity, appearing just where the math predicted. For over a century, Neptune remained largely enigmatic, just a fuzzy speck in our telescopes, a distant world shrouded in mystery. We knew it was big, a gas giant on a scale similar to Uranus, far and mysterious, but little else about its true nature. That changed dramatically in 1989 when Voyager 2, humanity's intrepid emissary, flew past Neptune after a 12-year journey across the solar system. Voyager revealed a dynamic azure world, a vibrant planet teeming with activity, with colossal storms like the Great Dark Spot, a swirling vortex larger than the Earth itself, faint rings composed of dust and icy particles and new moons, each a unique world in its own right. But Voyager's visit was brief, a fleeting encounter, a snapshot in time, leaving many questions unanswered. The Great Dark Spot, that massive storm, mysteriously vanished when Hubble looked years later, leaving us with new questions about the ever-changing nature of Neptune's atmosphere. How do Neptune storms form with such intensity and then disappear without a trace? What drives its wild weather, the fastest winds in the solar system, and the dramatic shifts in its atmospheric features? For decades we needed a new perspective, a more powerful eye to observe this distant world, a tool powerful enough to peel back Neptune's atmospheric layers and unlock its deepest mysteries. Now, with Webb, the James Webb Space Telescope, we finally have that tool, poised to reveal Neptune as never before. The story of Neptune is about to be rewritten, with new discoveries on the horizon, promising a deeper understanding of this enigmatic ice giant. To truly appreciate the stunning detail in Webb's view of Neptune, a world previously shrouded in mystery, we need to understand the nature of infrared light, a fundamental component of the electromagnetic spectrum. It's a type of light that exists beyond what our eyes can perceive. Our eyes, remarkable as they are, only see a narrow band of this spectrum: visible light. This is the light that paints the world in the colors of the rainbow. Voyager's iconic blue Neptune image, a familiar sight, was captured using this visible light spectrum. But beyond this familiar view, there's a vast universe of information, hidden from our direct sight, residing in light we can't see with our naked eyes. Webb is equipped to see in infrared. Specifically, it detects heat radiation. This means it can see the faint glow of everything warm, even objects we perceive as incredibly cold, because everything emits some level of infrared radiation. Think of it as having night vision goggles, but instead of just seeing what's in front of you, you're peering into the depths of the cosmos. Webb is able to detect the subtle heat signatures of planets near and far, stars in their various stages of life, and even entire galaxies across vast cosmic distances. So when Webb turns its gaze towards Neptune, it captures not only the sunlight reflected off its surface, but also the planet's own internal heat emanating from deep within and the unique chemical composition of its atmosphere. Neptune's atmosphere, rich in methane gas, strongly absorbs infrared light at certain wavelengths, causing the planet's disk to appear remarkably dark in many of Webb's infrared images. However, high-altitude clouds, floating above the majority of the methane layer, stand out, shining as bright spots and elongated streaks, because they are reflecting sunlight before it has a chance to be absorbed by the methane below. But perhaps most spectacularly of all, Webb reveals Neptune's faint, dusty rings, which have been nearly invisible and incredibly difficult to observe with other telescopes, now shine with an unexpected and breathtaking clarity. Webb's infrared vision is providing us with a whole new perspective on Neptune, presenting an ethereal, almost ghostly view, brimming with previously hidden details. This revolutionary new data is transforming our fundamental understanding of this distant ice giant. What was once invisible is now gloriously visible, and with each new observation, the long-held secrets of Neptune are steadily coming into sharper focus. When we think of planetary rings, Saturn comes to mind. But Neptune has rings too, faint, elusive, and mysterious. Discovered by Voyager 2, Neptune's rings appeared as incomplete arcs, barely visible from Earth. For decades, they remained poorly understood, whispers of a structure we couldn't grasp. Then came Webb's images. Suddenly, Neptune's rings appeared with breathtaking clarity, two bright, narrow rings encircling the dark planet, complete and continuous. Fainter dust lanes nestled between them, revealing intricate patterns never seen before. Scientists can now study the rings' composition and dynamics. Are they icy, dusty, or both? Rings are not permanent. They form and change as moons are torn apart or debris is captured. Webb's precision lets astronomers model how these rings behave and evolve. Neptune's rings are now a cosmic laboratory, helping us understand planetary systems everywhere. A blurry mystery has become a sharp, stunning reality. Beyond the rings, Webb's gaze pierced Neptune's chaotic atmosphere. In visible light, Neptune's weather is dominated by huge dark storms. In infrared, a new story emerges. Methane makes the planet's disk dark, but high-altitude clouds shine as brilliant white spots, beacons in the fog. These clouds, likely frozen methane ice, reveal circulation patterns in Neptune's upper atmosphere. Webb showed a band of bright clouds around the South Pole, hinting at a powerful vortex, and discovered a new vortex at the North Pole. Neptune's winds are the fastest in the solar system, over 2,000 kilometers per h. A bright, narrow band at the equator suggests a massive, planet-circling weather system, never seen in such detail before. Tracking these clouds lets scientists map Neptune's weather in 3 dimensions, measure wind speeds, and watch storms evolve. Neptune radiates more than twice the energy it receives from the sun, hinting at a mysterious internal heat source. Webb's data will help model this internal engine and its role in Neptune's violent climate. The planet's atmosphere is more dynamic and puzzling than ever. Neptune is surrounded by a family of moons, 14 in all. Webb captured 7 in a single frame, each a sharp point of light. The brightest is Triton, Neptune's largest moon, shining with dazzling brilliance in the infrared. Triton's surface is covered in frozen nitrogen, reflecting 70% of sunlight, making it outshine Neptune itself in Webb's view. Triton orbits in the opposite direction of Neptune's rotation, suggesting it was captured, not formed in place. This capture likely disrupted Neptune's original moons, shaping the system we see today. Webb can study Triton's composition, searching for clues to its dramatic past. By analyzing the infrared fingerprints of Triton and other moons, scientists can piece together the history of the outer solar system. Each moon is a fossil, holding secrets of ancient cosmic upheaval. Methane is central to Neptune's story, shaping its color climate and chemistry. In visible light, methane gives Neptune its blue hue and infrared. It makes the planet's disk appear dark. Webb maps methane's distribution with precision, revealing bright clouds of frozen methane ice. These clouds form when methane is carried upward by powerful currents, then freezes in the frigid upper atmosphere. The bright equatorial band seen by Webb suggests a massive planet-wide weather system. Subtle brightness variations hint at regional differences in methane or temperature details never seen before. Sunlight breaks methane apart, creating more complex hydrocarbons in a thin haze. By measuring methane and its byproducts, Webb helps decode Neptune's atmospheric chemistry. These insights reach beyond Neptune, informing our understanding of giant planets everywhere. Webb's images are more than pretty pictures, they're rewriting our understanding of the ice giants. For decades, Neptune and Uranus were mysteries with only one brief flyby and sparse data. Webb's clarity fills those gaps, challenging old models and sparking new questions. The ring's brightness and structure, new atmospheric vortices and detailed cloud bands provide the first global weather map since 1989. Neptune is now a natural laboratory for studying climate and atmospheric physics under extreme conditions. These findings also impact our search for exoplanets. Many are Neptune-sized, yet we knew little about our own. By studying Neptune in detail, Webb gives us a blueprint for understanding distant worlds. Every new image refines our place in the cosmos, reminding us that our solar system is dynamic and full of wonders. Neptune's story has evolved from a faint prediction to a complex, living world. Each discovery deepens our awe and expands our perspective. Every discovery brings new questions, and Webb's portrait of Neptune is no exception. The planet's internal heat and wild winds remain mysteries. How does Neptune drive such powerful storms? Webb's data makes the case for a future mission, an ice giant orbiter to map Neptune's interior and solve the energy puzzle. Triton's geology and potential for a subsurface ocean are tantalizing targets for exploration. Could it harbor the conditions for life? Webb will keep watching Neptune, tracking its seasons, hunting for new moons, and refining our understanding. The story of Neptune is just beginning. The universe is full of secrets waiting for us to look with new eyes.